Subscribe now and press the bell icon. Never miss an update.
So guys, this is Netra P Chand. Welcome to my mathematics class. Today we will study about the integration. So see here, very nice definition we have. So today we will discuss about the definition of integration as well as basic formulas, and then we will discuss some questions, basic questions based on the basic formula. Introduction. So look at here, introduction is the inverse process of differentiation. As we know already, we have studied derivatives. So if once you know the derivative, then integration is very easy because this is the inverse process of differentiation. Integration is also called the antiderivative, okay? Or a primitive also it is called. Integration is the inverse process of differentiation. The primary problem of differential calculus is given a function to find its differential coefficient. But the primary problem of integral calculus is just inverse. Give the differential coefficient of function to find the function itself, right? As you know, the differential coefficient means derivative of a given function, right? And in integration, we have to find out the inverse thing, okay, right? Integration is the inverse process of differentiation. Just like, okay, we have to, if we find the derivative of any function, that's called the okay or differentiation. When we find out the actual function, the process is called your integration. Okay, so now let's focus in the definition. Actually, this is the definition. uh, this one is the definition. You will see here, this is a mathematical definition. A definition, okay, let f of x, okay, f of x, your f of x, f of x, your, let f of x be a given function of x. If we can find the function f of x, this capital F of x, such that derivative this one is equal to f of x, then f of x is called the integral of f of x, and we write like this way. This is the math. Symbolically we can write down like this way, right? Now look at here, f of x is the given function of x. We can find out the function f of x. Let's suppose, okay, f of x, so that derivative of f of x is small f of x, right? Then this one is called your integral of f of x, right? Then this one is called your integral of f of x. Then only, okay, if this condition is satisfied, then okay, this one is called your integral of f of x, okay? Integral of f of x, okay? And we write, okay, symbolically this way, okay? You have to focus here also, how to write down the symbolically the same thing whatever we have said in just in one line, okay? Here, okay, symbolically, okay, this is the important thing. Symbolically we can write down like this way, right? Symbolically, integral of f of x with respect to dx means, okay, f of x with respect to x, we write out the integral of f of x dx is equal to capital F of x. According to this definition, this is the definition of the integral function, right? Integral of the given function, definition of integration. Okay, so after definition of the integration, the sign, okay, sign this the elongated is called the integral sign. The symbol dx indicates the integration is to be performed with respect to the variable x. Yeah, this will be dx indicates the integration is to be performed with respect to x. All right, the process of determining the integral of the function is called your integration, and the function to be integrated is called the integrand. For example, okay, here you can take, okay, for example, now look at here. For example, derivative of sin x with respect to x is equal to cos x. All right, cos x. Then Then okay, this cos 6, okay, here indeed the process of determining the integral function is called the integration. The process of integrating is called the, okay, the function to be integrated is called the, your integrand, right? So see this one, integrand, the function. The function to be integrated is called the integrand. Or for example, here with this example, you will clear derivative of sine x with respect to x is equal to cos x. Okay. Yeah, this cos x, and then okay, symbolically we can write down like this way: integration of cos x with respect to x is equal to sin x. And similarly, if we have a derivative of tan x with respect to x is sec square x, then integration of sec square x dx is equal to tan x. The symbol h, this elongated is an elongated s, which is the first letter of the word sum, as is approaches as the process of the integration originated from the summation of infinite series. Yeah, this is true. And why we use okay this letter? So from here is clear, okay, right? So originated this one, so you can focus here. So this symbol is elongated as, which is the first letter of the word sum, is the process of integration originating from the summation of the infinite series. So later you will know. So when we gradually do, we will later do this one also. Uh, we will come at the point where we use summation of the infinite series. The symbol this integration, sign of integration, you can say along, or elongated as, and dx separately have no meaning. Okay, so be careful about this one. Separately no meaning. These two symbols may be regarded as something like a pair of the brackets in which the function is to be integrated. Sorry. Okay. Now, so let's see the constant of integration. Constant of integration. Derivative of this one is derivative of capital f of x with respect to x is equal to f of x. Then derivative of f of x plus c, capital F of x plus c, we have taken with c constant. Then also you will have f of x. See, here also f of x, you can focus or say f of x, and here also you're gonna get the same result. Okay, here also f of x, here also f of x, here also f of x. Derivative of this one, f of x, derivative of this f of x, and derivative of f of x plus c also f of x. So instead of c, you can take any constant. Suppose if here 10 also, you're going to get okay f of x, and here if you have a 15, even then you can get here f of x. So therefore the integration of f of x, so finally we write on this one. Oh yeah, this one, integration of f of x dx is equal to f of x plus c, okay, right? And the arbitrary constant c is called the constant of integration. The arbitrary constant c is called constant of integration. F of x plus c is called the indefinite integral. Now that's why we say the indefinite, because of its indefiniteness, right? C may have any value. That's why, okay. So why we call it indefinite integral? Now I guess, okay, you understood, okay, right? So I guess you understood. So see, this is the very important line, okay, here to here, okay. These are the very important lines, okay. Why we say the arbitrary. The arbitrary constant c is called the constant of integration. F of x plus c is called the indefinite integral because of its indefinite where C can have any value, right? As I told you, okay, C can have a 10, C can have a 5, C can have any value, okay, whatever you have. But when you find the derivative of this one, you are going to get f of x, right? So okay, so here example also we have. You can go through that example. So let's go uh, through these examples, and they will provide us very strong concept of integration. So listen to me, everybody. Integration is one of the best. Okay, one of the best topics as we use in different parts of the subjects when we study the physics. Definitely you need, okay, if you whenever you try to study the physical chemistry at that time also you need, okay, and whenever you study economics, any other, okay, commercial mathematics, uh, nowadays, okay, in biological mathematics, mathematical biology, or biological mathematics, you can say. So you need, okay, there also, right? So that's why this is a very important, okay, topic. So this is mandatory to know for each and every student, all right? So I'm starting from the very basic, okay, concept. So if you're a layman, if you know only just derivative and you don't know about anything integration, you can see this topic, and definitely you're gonna get to each and everything. So a derivative of here, okay, as we know, again, derivative of x raised to power 5 plus 3 is equal to this one, 5x4. So if we okay, if we find the integration of 5x raised to power with respect to dx, okay, you will get, okay, here, just, okay, using this only, using this line only. So because here, okay, given, that's why we can write down this one, okay. If we write down, okay, this one, and we can, okay, 5x raised to power 4 dx, okay, x raised to power 4 plus 7, okay. Look at here, okay. So here, here, okay, integration of 5x4, x5 power 5, x raised to power 5 plus 3, here, and integration of 5x raised to 4 dx is equal to x to 5 plus 7. So there is a difference, okay, uh, in constant here 3, and here you can see 7, okay, right? They are different, okay, not so you are going to get the definite value, okay. That's why instead of here 3 or 7 in general we write down the c means constant, okay. All right, so let's move next. And one more thing over here, this primitive or anti-derivative, okay. So meaning of this one, integration, right? Integral. So a primitive or a anti-derivative, right? So meaning of this one, integral meaning of integral. So integral is also called, okay, a primitive or anti-derivative, okay. Now let's see the here, okay, basic formula. And so see, so just you can go through uh, things, okay, yourself, and so very simple, okay, right? So I take you just directly into the basic formula, and look at here, okay, and these formula you have to go through this formula. These are very important formula. So see, okay, formula, okay, we have just derived, okay, from the derivative, okay. Just if you know the derivative, then antiderivative is a formula, right? Anti reverse, here differentiation, okay, derivative of x raised to power n plus 1 with respect to x is equal to n plus 1 x raised to power n. In derivative we have studied already, and so just to give integration, so antiderivative this x, antiderivative x raised to power n is this one. So you have to know this formula, and you have to memorize, okay. If you memorize, okay, all these things, all right, so you can memorize both things, derivative formula as well as, okay, your antiderivative formula here, okay, antiderivative formula. These are the antiderivative formula, right? So just, okay, how we got, okay, these formulas, so you can see the differentiation, right? So how we have written these formulas, so I guess you will not have any problem. You can see this table, right? So using this table we have got, okay, here, right? So this formula, these are very important formula. Using this formula, you can, right? You can just, you have to memorize and you have to apply this formula. Very simple, okay? If you know one's formula, you can crack down very easily the basic questions, okay? So let's move. Let's move, okay? And here we have more formulas, so try to complete all these formulas. And one more thing here, see, here, so you know, right? Okay, derivative of x is 1 with respect to, that's why, okay, integration of dx, sorry, integral of 1 with respect to x is equal to x plus c. So you can memorize, and the integration of 0 dx is equal to c. As we know, the derivative of constant is equal to 0. So that's why integral of 0 dx, 0 with respect to dx, okay, with respect to x or with respect to any variable, okay, you can say here, you are going to get c, right? So integral of 0 dx is equal to, with respect to x, or you can say integral of 0 with respect to x is equal to, say, integral of 0 with respect to any variable is equal to, say, constant. Okay. So all right. So let's move. Okay. After knowing these formulas, how to apply, right? Some basic, okay, here. So basic formula and basic important, okay, theorem, you can go through these, okay, very basic, okay, very important, okay. So there you will not have any problem, and in this also you will not have here problem, right? So here also you will not have any problem, you can memorize, okay, while doing, okay, we need, okay, you can memorize this, and this statement also, while doing question, while doing practice, we need, okay, these concepts, right? Okay. So let's move into, and here, integration of the integral of the, you can read out, okay. So integral of the product of a constant and a function is equal to the product of constant and integral of function, okay. So not so, therefore you can understand yourself, and these are the steps, okay, integration with respect to x. Okay. So you can read out, okay, here also you can understand very easily, right? You will not get any problem, so you can memorize this also, this step we need, okay. So this one, it means, okay, separately we can write down, okay, from this you can understand, right? Okay. So let's move, and a very easy way, here we have done, you can go through that, okay. Example also, just, okay, see, okay, using, okay, example, okay, here. So if you have, okay, function in this form, so you can write down separately, integral of cos x plus integral of 3 cosec x with respect to x, and integral of minus integral of x with respect to minus x to power 5 with respect to x, this way. And now you can find out the integral of this, and the integration of this, and the integral of this, and the integral of this function you can find out, right? Okay. So I don't think you will have any problem. So some extension, you can, okay, we can go through that. So it's easy. So therefore to understand, okay, so let me, so you can, as a formula, you can, this one you can memorize as a formula, you can use, okay. And here also, yeah, it's very important. And here example given, see, you have to memorize as a formula, this one and this one. Here everything is written properly in the easy way, okay, you can understand. And here example taken, so you know, right, integral of x square x is 10x, and here using, okay, this formula you can write down like this way, right? So there is no problem, okay. So yes, this one already, okay. Now this one, Oh yeah, this one also integral of can. You can memorize this one also, right? Okay. This one, integral of 1 of x dx is equal to log of x plus c, right? Log of mod of x plus c. Okay, let's see. Next. Yeah. So how can we write down this one? Rewrite and integrate. Use the formula and simplify. Very simple way. Given here this one, this table. So layman also can understand if they know the right. If he knows about the derivative, then very easily we can understand, right? So integration, how to find out this table. And here some examples are there, okay? You have to just use the formula. I will not go in deeply. And if you go through it, okay, solution are also given. All solutions of all these questions are given, okay? Very easy, very in easy form, okay, given. Look at here. So just okay, integration of x raised to integral of x raised to plus 6 with respect to x. Just formula. We have used okay here formula, okay, right? Just okay. And here firstly we have to simplify and just open the square and write down separately. And then okay, you can just use the formula, right? And go through this. And if you have any problem, you can tell me. So very simple questions and okay. So nice, okay, nice question. These are very basic questions. And just firstly, okay, simplify before applying the formula of integration. Okay. So before integration, you can just simplify and then just whole cube formula we have used here. Here given whole cube formula also. Okay, so all right. And here, just simplify this upon this, a upon this, and b sine upon this, and you're gonna get this one, and this is also in formula, this is also in formula. Okay, so very easy question, right? So very nice, okay, very nice, okay, very nice, okay, very fantastic question, right? So for basic, okay, to understand the integration, please try to do these all questions and go through this. Okay, you will not get any problem. Okay. Mm. All right. So no problem. Okay. So very nice. Okay. Very nice. So see. Mm. Okay. So you can see just okay. Here, okay. You have to rationalize the denominator, and all you know very well. Where k is the constant of integration. Yes, again, I have a basic integration formula. Just okay. So again, okay, from the next book, I have taken okay from the different books. You can go through that. So same thing, formula. Here, okay, more formula, basic formula I've written here. I've taken here, so you can go through that. Okay. So I don't so think you have any problem. So if you go through this formula and the examples, definitely you're gonna get not so difficult. These are very basic things. Yeah. So more formula. So see, here simultaneously, okay, not directly formula written, firstly derivative and then okay formula, then formula of integration are written here, formula of integration are written here, some standard results on integration. So see, so very nice, okay, here. So everything okay, no? Just okay. Before this page also you have seen, and if you go through that, okay, you will get more you do, more you will get in mathematics. Practice, practice, practice. Okay. So very nice, okay, very nice uh, topic I've taken here, and with a very easy and full basic concept. So don't try to miss at any cost, and don't skip the video, so you will win loss, okay. And so nice, okay. See, in your book, okay, you can't get in the same time, at the same time, all things, okay. So with examples, okay, your solution are also given here. See, very simple question, very simple, okay. Just you have to use the formula of integration, and simple, okay. If you know the UK mathematics, simple mathematics, and you are just on starting, okay, if you know the formula and just starting, you don't know, suppose, okay, derivation, you just okay accept, okay, this formula as a universal tool, and you start, okay, you start to find out the integral of the given function. So definitely, okay, you can find out, okay, anyone can find out, right? So these are not so difficult, right? For the better concept, definitely you must have, okay, ideas of the derivative. So definitely there is no doubt. But for doing these questions, if you have a little bit, okay, if you have a okay, sound secondary level mathematical base, you can do, right? You can do, okay, if you have a mathematical sound base, okay, and good base. If you like the mathematics, you can. See. Good, a nice question. These are okay. This I have not explained. Okay, here already solution given. Solutions are already here, and simple. Okay, very basic. Okay, formula. Basic formula here we are using just like a plus b whole cube, as we have studied in low scan levels classes. Okay, and thereafter just okay write down separately and then use okay formula. Just you have to use formula. Okay, right? If you do all these examples, you will get some. Uh, background, some of working knowledge about the basic concept of integration. You get enough. Okay, these are the enough examples to know the basic concept of the uh, integration, which is the okay. And wherever you get again any example, please tell me and write down in comment, and definitely I will help you. Okay, there is no doubt. So say. So very nice. Okay, just firstly multiply and simplify, and thereafter write down okay, separately, right? So okay, and here some more examples. Okay, here just where we need okay little bit okay, uh, okay, where we need okay little bit a reasoning. So here given already these solutions we have. So nice. Okay, nice. Very nice. Okay, so interesting. Okay, and see, you believe the following integrals. Mm. So easy, okay, easy, right? So enough examples you are getting, okay, right? Evaluate the following integrals here. For these questions also we have solution. Just you need to know the trigonometric formula also, basic trigonometric formula. Okay, trigonometric formula, just basic formula. Okay, and using the basic trigonometric formula, we can do these questions, right? Not so difficult one. These are all right. So nice questions. These are very nice question, very good question. So definitely you will enjoy. Here, okay, examples. Some here. Evaluate the following integrals. Here, questions. So for practice, okay. So after doing okay, these all examples, please try to do these questions. These are very nice, similar type of questions. So if you get anywhere problem, you can tell me. These are very nice question, very interesting questions. Okay, right? And for your convenience, you are going to get also solution here, answers also I've kept here. Answers of all questions here given, right? Answers of all, okay. So I guess, okay, after doing, okay, these all questions, or you will not have any problem, okay. Mm, so good luck. Good luck for practice, okay. Okay, good luck for practice. Good luck. Uh, Thank you very much for watching this video and forget to share, like, and comment. All right. So thank you very much for watching this video, and don't forget to share, like, and comment. Okay. So I guess you will not have any problem. If you have any problem, please tell me. Feel free, let me know. Okay. So once again, that's all for today. Okay. Bye bye.